All right, this is 6th grade Excel, lesson 150, calculating the probability of two separate events as a sum and two consecutive events as a product, calculating permutations and using factorials. This is a stinking hard lesson, so you guys are going to need to really pay attention. You're probably going to want to watch it, back up the video and watch it about 20 times to get it into your head. Right, studio audience?
Yeah.
Yeah, here they are, my studio audience to help us out. Well, we better get going. We've got lots to do. Carl has a bag of 4 marbles. The colors are red, yellow, blue, and green. If he chooses one of them at random, the probability it will be yellow is 1 out of 4, or 1/4. Easy so far?
Yes.
Here are the 4 marbles. Oops, I better put it on. Oh, it is on pen. Let's make it a little bit smaller. Get over there. Okay, here are the 4 marbles right here. And they're in a bag. He just looks, he doesn't even look. He just reaches inside, picks out a marble to pick a yellow one. That's a 1 in 4 chance. 1/4 of the time he should pick yellow. This is called a simple event. It's just real simple. You just reach in, pick out a marble, and that's it, right? The following examples are different kinds of compound events. Now, you guys have seen the word compound before, having to do with words. Like doghouse is a compound word because it's made up of 2 words, right? Do you know what a compound sentence is?
Yes.
2 sentences that we join together to make one, right? We put an and in there with a comma or something like that. Well, these are compound events. Things that happen in math or in real life that are 2 things coming together. Gets a little bit more complicated than just one thing, like picking one marble out of the bag. Let's take a look at number 1, which is a compound event. If he chooses one at random, what is the probability he would choose a blue or a red? The probability of a red or a blue is calculated by adding their individual probabilities together. So the probability of picking a blue is 1/4. The probability of picking a red is also 1/4. And when we put 1/4 to 1/4, we add them up and get 2/4, or what, everybody?
1/2.
1/2, that's correct. So that's how to find the probability of 2 separate events that really don't have anything to do with each other. I either want to pick a red or I want to pick a blue. Picking a red does not make my chances of picking a blue any different. Okay, it's just 2 separate events. Here's number 2. If he chooses one marble at random and then, without putting the first one back, he chooses a second, what is the probability he will choose a blue and a red? A blue and a red. There are 6 possibilities since the order does not matter. So, blue and a red. It doesn't have to be a blue first. It could just be a blue and a red one. So if he picks 2 marbles, he could pick a red and a yellow, or a red and a blue, or a red and a green. Notice they kept the red all 3 times and put it with the other colors. Or pick a yellow with a blue. You wouldn't put yellow with red because you already did that here. Or yellow with green, and then the last possibility is blue with green. 6 different possibilities of how you can combine the different marbles together. So what is the probability of picking the red with the blue? Well, the way we figure this out is, first of all, we say, what's the probability of picking a blue or a red in your first pick? You got these 4 marbles, right? You got blue and you got red, and then you have yellow and green. What's the chance of picking a blue or a red first?
2/4.
2 out of 4. So that's my first probability, okay? And then after you pick one of those, let's say you pick the blue, now you've got these 3 left. What's the probability of picking the red one now?
1/4.
1 out of 3, right? The red's here, and then you got the 2 other colors you don't want to pick here. So the probability on the second one is 1 out of 3. Now to figure out the probability of actually doing this, of picking this red with the blue, we multiply the 2 probabilities together. So we do 2 times 1 is 2, 4 times 3 is 12. We can reduce that to 1/6. And if you look at the drawing, it makes sense that it's 1/6 of a chance. Because there are 6 different ways to do it, and this is the one we want to do, which is pick a red one and a blue one. Not too tough? Okay? And let's move on. It's going to get a little bit harder. A combination is a possible selection of events or items. Carl has a bag of 4 marbles, okay? Same situation, red, yellow, blue, and green. It's going to get a little more complicated. If he chooses 2 of them, what are the possible combinations? Okay, so we are going to say, what could he possibly pick if he just picks one out, puts it back in, and then picks another one out? What are the combinations he could make? Well, we could let's make the combinations. We could do red with yellow, right? We could do red with blue. We could do red with green. Help me out here, you guys. Okay, but could we also do red with red?
Yes.
Yeah, because he's putting it back in. So you could get red with red also. Okay, now, you could also get, now these are combinations. So, okay, now wait, this is actually combination, so that would not be correct. Let me erase that. Where's my eraser over here? Oh, there it is. Okay, so we're actually not going to be able to do that because I just realized that we are putting them back in. And this is the exact same problem as we did on the last one. So we have now yellow with blue, and we can do yellow with green, and then we can do what? Blue with green. Okay, so there's 6 different combinations. The way we abbreviate what we're doing right here is we write 4C2. And what this means is there's 4 different choices, 4 marbles, and you're going to make a combination, just combine 2's together, right? And you're going to do those in combinations of 2. That number 2 means you're going to pick 2 of them at a time. And they want to know how many combinations using 4 there are. And there are 6 different combinations. Okay, a little bit confusing. A permutation is a possible arrangement of a selection of events or items. What are the possibilities if Carl records the order in which the colors are chosen? Okay, same idea as the last one. We have 4 marbles, but this is going to be called a permutation, and you're going to pick 2 of them, and that means that the order actually matters. So you're going to pick first, let's take, let me list the yellow, what else do we have? Help me out, come on.
Red and blue.
Okay, blue and green. So the order matters this time in a permutation. Okay? So we can pick red, yellow, then what? Red, blue. Let's kind of go in order up here. Then red, green. Okay. And now we're going to go to yellow. So it could do yellow, what?
Yellow, red, blue.
Yeah. Is yellow red different than red yellow?
No.
Yeah. In a permutation, it is. In a combination, it's the same thing. But in a permutation, the order. Where does it say that up here? Okay. The order matters. Okay, so picking yellow first is different than picking red first if we're keeping track of the order that you pick the marbles in. Then we could do yellow with blue, good. Then yellow with green in that order. Okay, now we go to, what's the next item? Blue. Blue with
Green. Yellow.
I would do red first, right? Blue with yellow, blue with green, good. And then how about all the combinations that can be made with green, right? Green with red, and then green with yellow, and then green with blue. Okay, so these are, notice there's 12 of them this time. 3, 3, 3, 3. 12 different permutations, so when the order matters, you're going to get more of them. Okay, if he chooses a marble at random or he turns it to the bag and then he chooses a second, what is the probability he will choose a blue and then a red? Woo! Okay, so he's going to pick, he's got these 4 marbles again. He's got green, red, yellow, blue, right? He's going to pick one and then he's going to put it back, and he wants to choose a blue and then a red, so the order matters. So these are permutations. We've already listed all the possibilities that he could on the last page. Let's take a look at these. Let's figure it out maybe from the last page here. Okay, so these are all the different permutations. They want to know what's the chance that he picks what? Do you guys remember what it said?
Blue then red, I think. Yeah.
Was it a blue then red? Okay. So how many up here are blue and then red?
2. 1.
1, right? It's only that one right there. So the chance of doing that, how many different permutations are there?
1.
12, right? There's 12 different permutations. So the chances of doing that is 1 out of 12 for that last one. That's your odds of getting that one. Okay, when you have a large number of permutations, it takes a lot of room to write out the probability of selecting a combination of in a given arrangement. In other words, what if we didn't just have 4 marbles? What if we had 10 marbles and we had to make permutations out of that? You'd have this huge paper filled with all these different permutations, right? A shorter way of writing permutations is called factorial notation. Now, you're going to like this. This gets kind of easy here. A factorial is the product of whole numbers and every positive number less than that number. Remember, a product is the answer to a what?
Multiplication problem.
Good, multiplication problem. So 5 factorial is written 5 with an exclamation point. It is calculated by multiplying 5 times 4 times 3 times 2 times 1. That's what 5 with an exclamation point means. So 5, they didn't do that one for us, but here's the factorial. They did a 3 here. I don't know why they put 5 up there and then they did 3 for us. But 3 is 3 times 2 times 1, which is equal to 6. Okay? And you're going to do something like that. Here's 4 and here's 6. So go ahead and pause the video and see if you can solve what the factorials are for 4 and 6. Turn it back on when you're ready for the solution. Okay, help me out here now. So 4, what am I going to write for the problem for 4?
4 times 3
3
times 2 times 1.
Good. 4 times 3
12.
times 2
24.
times 1.
24.
So the answer to this one's 24. Hopefully you got that one right. Help me out with 6. 6 times 5
times
4 times 3 2 times 1. Woo! Okay, 2 at a time. 6 times 5
30.
times 4
120.
120. 120 times 3. 12 times 3. Come on, 120 times 3.
360.
360. Can you double 360 in your head? 360 times 2. 36 times 2. 360 times...
700.
There we go. 720 is the answer to the 6. Look at the difference of going from 4 up to 6. You went from 24 to 720. Gets a lot bigger. Thanks for watching.